Let's go.
Hey everybody, this is Mike from RototillerGuy. I wanted to do a quick video. I had some questions about how to use a multimeter to diagnose if the power is bad at the wall or if the timer is bad. You know, internally, this is called a transformer. So if the transformer is bad and it's allowing, so I wanted to go through how to use a multimeter. So here's a multimeter. I think I got this one on Amazon. I think this is maybe 40 bucks. I got this one from Harbor Freight, and I think this was 20 bucks. And then this is a kind of a top of the line one from Home Depot. This is kind of the best one that Home Depot has. And then when I asked all my electrician friends, because I didn't actually know at the time either. I just said, hey, what is the best multimeter? And guess what? They immediately knee-jerk response, Fluke. Fluke is the best. Why? And then I asked them, I said, hey, why is Fluke considered the best? Because they all do the same thing. And none of my electrician friends had the answer to why this is the best. Guess what? The reason why this is the best is because if you have a government contract to maintain anything at all government related, so it could be military like a tank or it could be just anything city or government related, they all write manuals on how to use they say, okay, you have to have the Fluke, you have to have this particular, and it's, each manual is a different model number of a thing, and then they tell you how to push this button and that button and click this and follow these directions. The reason why, because all of these are different, a tiny little bit different, but they don't want to give you multiple directions. They just want to give you directions on one multimeter. So all of their manuals are written for, let's say, this particular multimeter, and they don't want to change all their manuals. So the reason why this has become the standard is because they don't want to redo all their documentation. It's not because this is it is actually a better multimeter. As it turns out, this one can be calibrated. But how specifically, precisely do I need to measure things to do what I'm doing here? I don't. I just need to know if there's power or not, and if it goes, certain ranges. So you can spend $500-600 on this multimeter, or you can spend $20 on this one, and it'll do what we need it to do. I did not know that. I was only doing the research for this video that I found that out myself. Now, before you use a multimeter, do this first. This little thing here tells me whether or not I've got power. So you turn this on. It's got a little on and off switch here, and it turns a green light on. And if there's power in here, that thing will turn red. There's power in there. So I cannot tell you how many times somebody's paid me my minimum charge is $275 currently in today's economy. I got to say that because I got some really old videos out there, and my minimum charges change over years as the economy goes up. My prices go up because things cost me more. Anyway, $275 currently is what I charge as a minimum charge to come to your house. But I try to walk you through all this stuff over the phone. Now, you may not have all these things, but these are really inexpensive things. You can buy them at Harbor Freight, and again, they're like $5 and $10 items. Nice things to have around the house in the utility drawer somewhere. But before I stick anything into an outlet, I check to make sure I've got power. And man, I cannot tell you how many times I've gone to somebody's house for $275, and all that's happened, they have a GFI plug, and they've clicked this GFI, the breaker in here has clicked, and now there's no longer power in here. Actually, here, this is the test. So that's if the breaker has been popped, and now I no longer have power, right? And then I quickly put this in there and go, oh, there's no power. Or I plug in a lamp or a drill. I got no power to the outlet. Oh, okay, well, let's hit the reset button. oh, magically, all of a sudden now I have power and your timer works and everything's back up and running, but now I want to charge you $275 to drive over to your house. Oh, you're going to rip me off like that? Well, no. See, I just spent an hour driving to your house or however long. My time is valuable to me, and I've got to charge something. I tried to walk you through this over the phone. You could have plugged in a lamp or a drill to test your outlet and then go over to your breaker, you know, at the breaker switch, or hit this button in your GFI plug. So I tried to tell you to do that over the phone, but you don't want to do it, right? By the way, this is a nice little tool too to test. This is a really cool tool to test. Let me turn this on. And then maybe I don't have batteries in it. Anyway, but I can plug this in and I hit test, and it will cause the breaker in the plug or in the breaker panel. It'll throw the breaker. And so this is testing that the breaker is good, that the breaker is doing its job. I think my batteries are dead on that one. So anyway, the first thing you do is you check to make sure you've got power. And so it's a red light, means you'll get shocked if you stick your finger in there. So that means you've got power. That's a good thing. All right, so we know we have good power here, right? Now, we can also check it with the multimeter. So here, I got this is the cheapy one. And some of these, now this is where I'm talking about the differences in different multimeters. So this is continuous power, that is a battery. And when it has a little wave sign like that, that means alternating current. What you have on the wall is alternating current. And you want to set it to 200 in this case. Now every one of them is a little bit different. See, this one's got voltage with alternating current. So this is where I would put it there for alternating current. And this one doesn't even have a battery. No, this one doesn't have battery. So you can't check your battery on this one. So maybe that's not as cool. And then this one is going to be way high end. And so again, you look for there. So the reason they're all in different places, and that's why you need a different set of instructions to use it. See, this one's the first one is alternating current rather than being way over here. It's right there. So if you were writing a manual, you'd have to change the manual for every one of these multimeters, and that's why the government has just picked a single meter so they can write one set of instructions to maintain whatever piece of equipment. And because the government chose that meter, and because of and you can calibrate that meter, I cannot take this somewhere and get it calibrated, but I can calibrate that one. And because of all the manuals, and they're able to charge more for it because now they've got you locked in. All right, now, when you if you use a multimeter to check an outlet, there is a way to do it. So for instance, if I put this in here first, like so, hang on. If I put that in there first, like so, let me just hold that. And then if I test this side, guess what? Look at it, it's hot. So if you just happen to touch that and you're grounded, you'll get electrocuted. So what you're supposed to do is you're supposed to put the neutral side in first and then put this side in, and that'll give you a reading on your multimeter, and it should be about 120. So again, this is not a very calibrated one. I'm sure if I were to put one of the other, all four of these is going to give me a slightly different reading. But this one's probably going to be more calibrated. This is close enough. I know I've got about 120 volts in here, and that's all I need to know. I just need to know there's power, right? So be careful not to electrocute yourself a little bit there. If you're going to get 120, it's going to be slightly uncomfortable. Not good. Don't be standing in a puddle of water when you're doing it. All right, so now, if my timer has power, and I have electricity. Now my timer lights up. Okay. Now it's also telling me that my backup battery, this particular timer tells me that the backup battery is running low. This one, the backup battery is right here. So what's the backup battery do? If the power goes out, and let's just cause the power to go out. I'm gonna use this thing so that way, okay? I've just turned off the breaker on the switch, and guess what? It says right here, no AC. This timer will tell you that there's no alternating current, there's no house power, right? And that's when people call me, right? And all they got to do is go over here and touch this switch. But my point is that because we have a battery, we didn't lose all the programming in here. The battery, all it does is hold the programming as to what time it's going to go off and how long it's going to run on each zone. So that's all the battery does. It cannot run the zone. Okay. So that's the battery. Now, I mentioned that, so this is 120 volts coming through this thing, and it goes into this thing's called a transformer. And so it should transform power. This is AC out. So I should be able to put my test probes in there and check that it's getting 24 volts. So I would do that. I would do this. I would just push this into there, and I should get not 120. I should get 24 volts. So this is transforming the 120 to 24 volts. So this is all this can handle, and that's all these valves are rated to handle. So this is transforming the power down to something that we can acceptably use. That's what this is. So if this doesn't give me 24 volts, then my transformer has gone out on my timer. So it's time to replace the timer. Or you can sometimes replace the transformer and still salvage the timer, but that takes a little effort on your part, and I would just go get another timer if it was me, because they're relatively cheap. All right, now if I told this thing, let me just set the program really quick. Actually, did I turn off the power? I think I turned off power. Yeah, so I don't have power. Let me reset it. Yeah, now I've got power again. Yep. So, and now the light comes back on here. So let me set the clock. Let's just say it's 1 o'clock. It's actually, right now it's 3:30, so I can just set it real quick. It's actually 3:25. Right, and it's PM, so good. And we hit enter. And then set the date. It's 2024. And it is February. And what is today? Is the 16th. It's pretty easy to do. All right, that's done. Start time. I recommend having the timer for your sprinklers go off at about sunrise. Sometimes people are in the shower at the same time as sunrise, so you don't want this to run while you're in the shower, because that reduces your water pressure while you're in the shower. So maybe you do it a little before you wake up in the morning. Maybe this is the, so you want to just run this not while you're actually in the shower, maybe after, but not after 9 a.m. or you'll get a ticket from the city of LA. All right, and then, so let's just set it, so 5 a.m. We're just going to allow it to be 5 a.m., okay? And enter, and then I can set multiple run times, but I'm just going to leave it at one. Start times. And now run time, I want the zone, let's say for 15 minutes. Okay, and then how often I want Monday, Wednesday, and Friday. See, it puts this timer puts a box around the day that it's running. And then I set it to auto. So this this timer has been programmed, okay? But it's still not wired to the valve. So inside of here, we have the white wire is in the common, common right there, and it's white, and the white wire is in common. And then I have two wires going to station 1 is going to be blue, and the red one's going to be station 2. Okay, so in my case, I've only got the one valve. By the way, this is a Rainbird valve, very nice valve. I slightly prefer the Hunter valves when we're talking about plastic valves. But when you're putting a plastic valve and it daily is in the sun, guess what? Plastic is not UV rated, and the plastic becomes brittle, and then all the rubber parts inside of there get beaten up by the UV rays of the sun. If you go with a brass valve, the sunlight's not penetrating through the metal brass, and it's not eating up all the rubber bits, and it'll last maybe twice as long. It costs more though. So I use them both. I like, if it's in the shade, it's fine to use the plastic. I tell people if it's in the sun, I would go with the brass, but you can go with plastic. Plastic are cheaper, and there's a difference. I think I charge 120, or it's either 120 or 130 for a plastic valve installed, and I charge 150 for a brass valve installed, which means I'm buying the valve and I'm doing all the plumbing on it. Now, what color did I say? So blue. So the first zone is going to be blue. So one wire from each valve gets connected to white. So if I had 3 valves, I'd have 3 of these connected to this white cable, right? Because that's the common cable. It's common amongst all the valves. And then this color, because it's in station number 1, this other wire gets connected to station number 1 or 2 or 3 or 4. And those are going to be, this might be station 3 or 4, so it just depends on what order I've got them plugged into the timer as to what number. So blue is station 1, and station 2 happens to be red in this case, right? All right, so, and I would put some wire screws on there. Right now, there's no electricity going here because this timer hasn't said send electricity. I am not going to get shocked by touching this, and I'm only going to get shocked by 24 volts. It is not going to hurt. Right. So if I've programmed, I've got it programmed, I have electricity, the timer's working properly, I've checked it, it's getting 24 volts to the outside of the transformer, and now what I want to see is that it sends 24 volts to these wires. So I'm going to tell this to run. Okay, I haven't turned on the water, so this is not going to actually run yet. We should hear it click. So I'm going to go manual, and in my case I can hit all, or I could just go manual, and I could go to station 1 and tell it how long I want it to run, and hit enter. So it should click, and it did. I can feel it shaking right now. But now the more important thing is, so the white is the common or the neutral, and the blue, and look at the number, I'm getting 25.9. Very close to 24, right? Again, this is not a super calibrated, this is a little $40, but it serves our purpose. This transformer is now sending 24 volts to this side of the wire, right? To this end of the wire. Now, I wonder if I'm getting 24 volts at this end of the wire. Now I do have a live electricity here, but it's only 24 volts, right? But anyway, I'm going to click this and touch this. And there we go. Same number, 25.9. So that means this wire hasn't been broken. Okay, now this wire, that bundle of wire behind you there. So this wire, this is just a representation of wire, but that wire could be 100 foot long, right? And by checking this end of the wire and then that end of the wire and getting the same number on my multimeter, I know that this wire has not been broken. The gardener didn't hit it with the weed whacker. The dog didn't chew on it and break the wires. So in theory, I'm getting 24 volts here. The next thing that could fail, by the way, I can feel it's running. It is running right now. But if that solenoid, this is an electromagnet. When this is sending electricity to this thing here, this is now getting power, and it becomes an electromagnet. And it magnetizes a little rod inside of here. It lifts it up because it's attracting it. It's magnetized, and then it opens up the valve, and water's running out through your sprinkler. So I just don't have this. I can connect it up to the hose, and I'll show you. It's run. I can literally, and it just turned off actually, because I only ran it for 2 minutes. So it was running, but if it were not, if I had 24 volts here and it still was not running, I would begin to diagnose the $15 solenoid. And the way you could check the solenoid, right now I don't have power. So what you could do is you could put this to, you should help me with this one. Okay, so now I go to resistance, and I think I go to 200 or do I go to just, no, I got to go I got to go higher than the value. I'm expecting 24.
Go to that one right there.
Well, no, that's continuity, isn't it?
Right.
Well, continuity is whether or not the wire is broken. So I could check continuity too. And what I would have to do is touch both ends of the wire to test continuity. But what I'm trying to do, I want to check that I'm actually getting 24 volts. So I think I got to go to 200 because I think 2K is 2000. So 200 is the smallest. And this is 20,000. That's a ridiculous amount. But so right, I'm looking. No, actually, so I'm looking for resistance. I might want just the What is milli? Is that million or million? Milli. Is that small or large?
Oof. Large.
That's large, so that's too much. All right, I'm going to put it at 200. I think we can start here. Let's see what happens. What I should see is I'm looking for resistance on the solenoid. If it's got a broken wire inside, it will not resist because the wire is broken. So by running this test, so I put it on neutral, and then I put it on the contact here, and then I get a reading on my multimeter. If I had a 0 or you might get a out of range or a OL. What is OL? The OL stands for out of level.
Overload.
Sorry?
Overload.
Overload. Okay, overload. So I'm out of range. But if I get a reading, that means the solenoid is good. If I get a 0 or an overload, that's either a short or an open circuit in here, and it's bad. So it's just time to replace. Now I could also do the same test right here. I can do it at the. So that's. I should get the same value here. Yeah, 46, 44. And what it's testing is I can test it here or test it closer to the valve to see if I'm getting resistance there and I don't have a bad solenoid. So, I'm getting power, I'm sending power to it, but it's got a broken wire inside of it, so it's not going to work. It's not going to, and that's how you test whether this is good. So again, you're using your multimeter to check that you have electricity, that the transformer is transforming the 120 to 24, and then you're checking continuity of the wire, however long it may be, and then you can check whether or not the solenoid is bad. If all of those things check out and it still doesn't turn on, then it's going to be an internal problem to the valve. Okay? So basically that's the end of the video. I just wanted to go through how you can use a $10 or $20 tool. Any of these would work. These all do the same thing. They're just not going to be super calibrated and beautiful, but they're going to say yes or no. I'm looking for yes or no answers. Do I have electricity? Is my transformer transforming the 120 to 24? is the 24 going across the wire? Is the wire broken or not? Yes, I still have 24 here. Okay. Then I can check the resistance on my solenoid with the same tool. And then if that's, then it turns into a problem with the valve itself. I know that's kind of a long video, so I apologize. There's kind of a lot to fit in, and I hope that's precise. But if you have any questions at all, please comment on, down at the comments, or give RototillerGuy, RototillerGuy.com. I have 6 different phone numbers. Call any one of them, and I'll talk to you over the phone. I talk to people for free before I come out to your house. So I try to walk you through all this over the phone before I charge you $275. Now, some of you just go, you know what? You obviously know what you're going to do, what you're doing, and I'd rather than me fooling around with all this stuff, I'd rather just have you out. So, and that's fine, but just realize when I show up and all I do is push that button, I'm still going to charge you $275 because I could have gone somewhere else and made that money. So it's just fair to me. I'm not trying to rip you off, and that's the whole point of this video, is to help all the people that want to go do it themselves. And I'm more than happy to help you over the phone for free. But if I come out to your house, I'm going to charge you for my time. All right. Signing off, RototillerGuy. I hope everything goes well for you. Thanks. Bye.